In this video, I'm going to explain some examples on complex fractions. Complex fractions are the complicated fractions where the numerator and denominator, either numerator or denominator or both, have fractions in themselves. So there's fractions involved in the numerator or denominator or both. Earlier, we've talked about the negative a over b is same thing as a divided by negative b. It is same thing as negative of the fraction a over b. There's two methods to simplify complex fractions. It will be your choice whichever method you use, but I'm going to mainly focus on the second method in the examples. The first method, we determine the LCD of both numerator and denominator and multiply numerator and denominator by that LCD. This clears denominators of both the fractions. But I'm going to be focusing on the second method where I'm going to make the single expression in the numerator and a single expression in the denominator. So I'm going to concentrate on the numerator separately and the denominator separately until they both are, until I come down to both of them as a single fraction. Then by treating both numerator and denominator as separate fractions and finding common denominators of each individually. Then we divide the two fractions by multiplying top fraction by the reciprocal of the denominator. It will make more sense after seeing some examples. The example number 1 here, it's done for you. Spend a minute and see if it makes any sense. So this is our problem that we are required to simplify. As you can see, there's a fraction in the numerator and fraction in the denominator. So my goal is to get the numerator into a single fraction and get the denominator into a single fraction. So to get the numerator into a single fraction, I need to find the common denominator for the two fractions. Looks like it would be x, and the first fraction needs to be multiplied top and bottom with an x to have the common denominator. So it leaves me with 3x over x minus 1 over x. And same thing for the denominator. The common denominator would be x. Again, the first fraction needs to be multiplied top and bottom with an x. And once we have the common denominator in the numerator, I'm ready to combine the numerators of the numerator and write the common denominator as a common denominator. And same thing with the denominator. I'll combine the numerators and write the common denominator as denominator. Next step, instead of writing this division line, I'm going to think of it like a division symbol. So this is the problem I'm dealing with now, x plus 1 over x. And we know division is same thing as multiplication, except you flip the fraction on the right hand side when you change the division problem into multiplication. So division is not the same thing as multiplication, but division problem can be written as a multiplication problem by flipping the fraction on the right hand side or flipping the second fraction. So we do that, and now we can cancel the x between numerator and denominator, and the remaining numerators and the remaining denominators, or product of remaining numerators and the product of remaining denominators, will be our end product, simplified complex fraction. Let's look at another example. Here's our example number. I'm going to go to example number 3 and then do number 2, okay? For number 3, let's see. I do have a complex fraction because there's fraction in the numerator and fraction in the denominator. I'm going to treat the numerators and denominators separately here. So for a minute, cover up the denominator, only look at the numerator. What would be the common denominator for the top fraction? Only look at the yellow highlighted fraction. What would be the common denominator? I'm trying to get that top numerator into a single fraction. My goal is to get the top into a single fraction and the bottom into a single fraction, both numerator and denominator as a single fraction. So it looks like the common denominator would be x here. So I do need to multiply top and bottom, both numerator and denominator, of the first part of the fraction with x to get the common denominator. X times 1 is x. So when I combine it, add or subtract these, my common denominator is x, and I will have x minus 2 in the numerator. Now let's focus on the denominator, and I'm going to highlight it green. Let's focus on the green highlighted denominator. What would be the common denominator here? Well, it would be x again. My second fraction already have the denominator x. The first fraction does not. So let's multiply top and bottom with an x. X times x is x squared minus 4. Okay, now instead of this long blue division line, I'm going to be using division symbol. And this problem will look very familiar after it's converted into a multiplication problem in the next step. So dividing fractions, dividing rational expressions, we change division into multiplication and we flip the fraction on our right-hand side. Okay. Now, when we multiply rational expressions, we are supposed to factor every single expression. X squared minus 4 is difference of square. This will factor into x plus 2 times x minus 2. And let's go ahead and cancel x minus 2 and x minus 2, x and x, and we are left with 1 over x plus 2. Okay, and that's our final answer, and that's our simplified complex fraction here. All right, let's look at example number 2. We have 1 over z plus 4 over z minus 3 divided by z over z squared minus 9 plus 1 over z minus 3. All right, let's focus on the yellow highlighted numerator only. What would be the common denominator for that? The common denominator would be z times z minus 3. The first fraction will need to be multiplied with z minus 3. The second fraction will need to be multiplied with the z. Okay, so it turns out to be z minus 3 plus 4z, and we got our top numerator into a single fraction now, except that I need to combine some like terms in the numerator. Now for the bottom, let's think about z squared minus 9. It is factored into z plus 3 and z minus 3. When you factor z squared minus 9, it factors into z plus 3 and z minus 3. What would be the common denominator in the denominator? Well, the common denominator will be z plus 3, z minus 3. The first fraction already has them both, but the second fraction has to be multiplied with the z plus 3 in numerator and denominator. So it turns out z plus 3. Now, instead of using the blue division symbol, instead of using blue division line, I'm going to be using division symbol there. And also combining like terms at the same time. Z plus 4z is 5z minus 3 over z times z minus 3, dividing by 2z, because it's 1z plus 1z, 2z plus 3, divided by z plus 3, z minus 3. All right, let's try and simplify it now. Change this into z times z minus 3 times z plus 3, z minus 3, divided by 2z plus 3. All right, so z minus 3 and z minus 3 is gone from here. Let's see, all we are left with is 5z minus 3 and z plus 3 in the numerator, and z times 2z plus 3 in the denominator. And that's our final end product. Nothing else can be simplified. We cannot cancel z plus 3 and 2z plus 3 between numerator and denominator. They are very different from each other. They are two different binomials, so no canceling possible there. Example number 4, again, complex fraction, because I have fractions in the numerator and fractions in the denominator. Let's go ahead and first focus on the yellow part of the numerator of the fraction only. The common denominator would be y squared for the top fractions. The first fraction already has y squared. The second fraction does not have y squared. So we would be multiplying the second fraction top and bottom with a y. And now let's look at the denominator. Make it pink just to keep it distinct. Let's look at the green highlighted portion now, which is your denominator. Again, I need the LCD for the denominator. That would be x squared. First fraction already has an x squared. The second fraction does not have an x squared. So we'll need to multiply top and bottom with an x for the second fraction. Let's see what does it simplify to. Instead of writing the division line, I'm going to be using division symbol now. Y plus x over x squared. Okay, we know when we are dividing two fractions, change the division into multiplication and flip the fraction on your right-hand side. Because addition is commutative, y plus x and x plus y is the same thing. Let's go ahead and cancel the common factors. between numerator and denominator, and we're left with x squared over y squared, and that's our end product. So that's what this fraction simplifies to, this complex fraction. Example number 5 here. Good thing my numerator is already a single fraction. So if you look carefully, my numerator is already a single fraction. Not much work required there. Let's focus on the yellow highlighted denominator. That is not a single fraction. So my goal is to start by getting a single fraction there. So the common denominator here would be x minus 3. So I'm going to have to multiply the first fraction, numerator and denominator, with x minus 3. The second fraction already has an x minus 3. Once you have the common denominator, you can combine the like terms in the numerator. So numerator becomes x minus 3 plus 1, because when I distribute the 1 here, that doesn't make any difference. Now I'm going to write it as a division problem. So instead of using this blue division line, I'm going to be using the division symbol. X minus 3 plus 1 is x minus 2 over x minus 3. Let us go ahead and change the division to multiplication and flip the term on the right hand side, and it would leave us with this is a multiplication problem now, and we can factor the numerator. We can factor the denominator of the first fraction, x squared minus 9. That is difference of squares. So difference of squares. Now let's cancel all the common factors between numerator and denominator. And my final end product is 1 divided by x minus 2. Don't forget to keep 1 on the numerator. That's your placeholder, because x minus 2 is in the denominator. And everything in the numerator cancels, so there is a 1 for the placeholder for the numerator. Okay, example number 6 looks a bit complicated, but let's check it out. Good news that the denominator is already a single fraction, so I don't need to do much work for that. But the numerator is not a single fraction, so let's go ahead and work on getting a common denominator for the numerator. For the numerator, common denominator would be x plus 2 times x plus 7. So multiply the first fraction top and bottom with x plus 7, and the second fraction top and bottom with x plus 2. I'm going to distribute 2 here, distribute 6 as well. Okay, so that will leave me with 2x plus 14 plus 6x plus 12. And my denominator already is a single fraction, which is a good news. Now, instead of using the pink division symbol, I'm going to be using, instead of pink division line, I'm going to be using pink division symbol here. So 2x plus 6x is 8x. 14 plus 12 is 30, divided by x plus 2 times x plus 7. This fraction is being divided by 4x plus 13 over x squared plus 9x plus 14. Now let's change it to a multiplication problem. And when we change it to a multiplication problem, division changes into multiplication, and we flip the fraction on the right hand side. Now it is time to take care of this multiplication problem. Factor every single expression, cancel out the common factors between numerator and denominator, and whatever we're left with is going to be our final product and solution. Okay, so it looks like I can pull out 2 from 8x plus 30. So if I pull out a 2, I would have 4x plus 15 here. 4x plus 15. Yep, 4x plus 15 would be left there. And then I have x plus 2x plus 14, 6x plus 12. Okay, 14 plus 12 by mistake. Please fix it. 14 plus 12 is 26. Sorry about that. It's not 30. 40 plus 12 is 26. My bad. So there's 26 here, and this will be 13. Okay, and then we have x plus 2 x plus 7 times, let's go ahead and factor x squared plus 9x plus 14. Two numbers multiply to give you 14, add up to give you 9 are x plus 2 and x plus 7. 2 and 7 will be your special numbers. Let's cancel out all the common factors between numerator and denominator. And whatever we're left with, the remaining part is going to be our solution. So we're just left with 2 in the front. And it's in the numerator. So no need to put 2 over 1 because 2 divided by 1 is still 2. So just leave it as 2. Example number 7. Number 7, the numerator is nice, single fraction. Denominator is not nice, not a single fraction. So let's work on getting the denominator as a single fraction. It involves a bit of work because I cannot see what the common denominator would be until I factor x squared plus x minus 6. So two numbers that multiply to give me negative 6 and they add up to give me positive 1 are 3 and negative 2. So now it's a bit easier to think about the common denominator for the denominator fraction, which will be x plus 3 and x minus 2. Looks like the first fraction needs to be multiplied with x plus 3. Second one is good the way it is because it already got both x plus 3 and x minus 2 in the denominator. So my numerator is 2x plus 6 minus 1. So 4 divided by x plus 3 over 2x plus 5 over x plus 3x minus 2. All right. Now let us go ahead and change that division line into division symbol. So 4 over x plus 3 divided by 2x plus 5 over x plus 3 times x minus 2. Right, so 4 over x plus 3 times x plus 3 times x minus 2 over 2x plus 5. Now let's cancel out the common factors between numerator and denominator. X plus 3 and x plus 3 is gone. All I'm left with 4 times x minus 2 over 2x plus 5. Okay, and that's our end product. There's not much to do now. And that's where we would leave. Nothing else can be canceled between numerator and denominator. If you're thinking you can cancel between 2 and 4, that is not correct. And same thing, canceling x between numerator and denominator, that's not okay as well because they are not in the factored form. Let's look at another example. Here we are dealing with the negative exponents. So first thing I'm going to do is take care of the negative exponents, make them positive exponents. Negative exponent we have seen before, x to the power negative 1 means the same thing as 1 over x. Same thing, y to the power negative 1 is same thing as 2 over y. So 25 over x squared minus 4 over y squared. Now it is time to get a common denominator in the numerator, which will be x and y. The first fraction needs to be multiplied with an x, the second one with a y. So 5y minus 2x. For the denominator itself, let's use a slightly different color here. So denominator would be x squared y squared. The first fraction needs to be multiplied with y squared. The second fraction needs to be multiplied with an x squared. So 25y squared minus 4x squared. 5y minus 2x over xy is being divided by 25y squared minus 4x squared over x squared y squared. Let's change it to a multiplication problem. Turns out to be x squared y squared over 25y squared minus 4x squared. Let's factor every expression that we can. 5y minus 2x cannot be factored. Xy cannot be factored. X squared y squared is already in the factored form. And 25y squared minus 4x squared is a difference of squares. So 5y plus 2x and 5y minus 2x. These are my two factors for that difference of squares. So 5y minus 2x cancels between numerator and denominator. All we are left with xy in the numerator and 5y plus 2x in the denominator. Right, that was example number 8. And let's check out this one as well. And we'll just call it example number 9. 1 minus 4 over x squared divided by 1 minus 7 over x plus 10 over x squared. So taking care of the negative exponents first. Now I'm going to try to get a common denominator in the numerator. That would be x squared. The first fraction, top and bottom, needs to be multiplied with an x squared. And getting the common denominator in the denominator itself would be x squared again. The first fraction needs to be multiplied with x squared. Let's use a different color here. The second fraction needs to be multiplied with an x. And the third one already has an x squared. X squared minus 7x plus 10. Now let's go ahead and write this fraction as, instead of using division line, use division symbol to divide these two fractions. When we use the division symbol, we leave the first fraction as it is, and we change division into multiplication and flip the second fraction, okay? This becomes a divide. Instead of division problem, it becomes multiplication problem. X squared over x squared minus 7x plus 10. Cancel out the common factors between numerator and denominator. And let's factor the numerator and denominator as well to see if we have any common factors between numerator and denominator. Two numbers that multiply to give me positive 10 add up to give me negative 7 are negative 2 and negative 5. There are common factors between numerator and denominator, and final answer would be x plus 2 over x minus 5. Again, word of caution, do not cancel the x and x. They are a part of binomial. That's a big no to do that. The x is not sitting in the factored form, so we cannot cancel it or get rid of it. Okay, it's not factored. It's a part of the binomial. When pluses and minuses are attached to it, it's a binomial, so you cannot get rid of that. Okay, remember